Okay, due to request, I am posting this video for section 10.6. Some people wanted to see another example of a maximizing and minimizing problem in two variables worked out. So here we go. So I'm going to do out of section 10.6, I'm going to do number 10 from the homework problems. Alright, and so number 10 says we want to maximize and we want to find any extreme values, or actually find the critical points and determine what kind of points those are of this function. So f of x, y equals y sine x. And so the first step is we want to find the critical points. Which means I take the partial with respect to x, set it equals 0, partial with respect to y, set that equals 0. And then as long as this is true and this is true, so these have to be true simultaneously, then I have a critical point. Alright, so first things first, we find partial with respect to x, which is going to be y cosine x. Okay, and we set that equal to 0. Well, that is equal to 0 when y equals 0 or cosine x equals 0. Okay. Now this is kind of a special case over here. Cosine x equals 0 means that x, well, x could be, so remember cosine is 0 at, draw a little unit circle off to the side. So you see there, it's a very rough looking unit circle, but the cosine is 0 at pi halves and 3 pi halves, right? And then again, if I make another turn here, this is pi halves could also be called 5 pi halves, then 3 pi halves could be 7 pi halves, and then 9 pi halves, and then any odd pi over half. So x equals 2k plus 1 pi halves. So 2k plus 1, so for k an integer, so what we're looking at here is these are all the odd numbers times pi over 2. You likely won't see a problem where you have to do all this on a quiz or exam, but it's good to know that cosine of x is 0 at all of these points. So back to the point, we're looking for critical points, so the partial with respect to x is 0 if y equals 0 or cosine x equals 0. Okay, and then the partial with respect to y, so partial with respect to y, so remember we started with y sine x, so partial with respect to y is actually just going to be sine x. Okay, set that equal to 0. This tells me that x is equal to, well, this will be all the cases where x is the even pi, so cosine x is equal to 0 anytime that this number here is odd. Sine is equal to 0 whenever that number is even. So we just do 2k pi over 2, which is actually just going to be at all k pi. Okay. So, okay. So now what are my critical points? So here's the key. This partial with respect to x is 0 when y equals 0 or cosine x equals 0. So I have these two cases. These are two separate cases, right? And down here, this partial with respect to y is equals 0 when x is k pi. So what we have here is actually, there's an or in between these two, but in between these partials, there's a big and. So both of these partials have to be equal to 0. So I can go back up here, I can say partial x is equal to 0 and partial y is equal to 0. So that means I come down here. So now what are all my points? So partial x equals 0 and y equals 0. Okay. So if I choose, so I just have to choose one of these. So if I choose y equals 0, great, I come down here, x is k pi. So at all my k pi 0. Okay. So these are critical points. And then, so that's all my y equals 0, come over here. Now x is 2k plus 1 pi over 2. So I need that to be true and this to be true. X is k pi. But you can see these are kind of at odds with each other. I can never have x be both 2k pi or 2k plus 1 pi over 2 and k pi. These are all different parts of the unit circle, so I actually can't have this and this. So my only cases are where y equals 0 and this is true. So I actually have infinitely many critical points, but they all look like this. K pi and 0, where k is some integer. 0, 1, 2, 3, negative 1, negative 2, negative 3, and so on. Alright, so that's important. Okay, so these are my critical points. Are these maximums? Are these minimums? Are these neither? Are they saddle points? Well, to do that, we need to find Hessian. So up here I could label this find the critical points. This is really step 1. Finding the Hessian is going to be step 2. So the Hessian is, remember, this guy. Hessian of f of x, y, is really, and I'm going to abbreviate, second partial with respect to x at xy, partial xy at xy, partial yx at xy, and partial yy at xy. Okay. So I just got to go up to these partial derivatives here and take my second partials. So I look at this guy. What's the partial derivative of y cosine x with respect to x? Okay, so cosine goes down again to be sine, but from cosine to sine it's going to be negative. So in our case it'll be negative, oops, there should be a y in there, sorry, negative y sine x. Right, take that partial x with respect to y now. Where'd it go? Here's my partial x. Take this derivative with respect to y, just becomes cosine x. And the real test, this is a nice continuous function, it's just defined with y and sine. So hopefully my mixed partials are the same, so hopefully this guy down here will also be cosine. So now I'm going to take partial with respect to y and take that next derivative with respect to x. I don't know if you can read that on the camera. So partial y with respect to x, so sine x, the derivative with respect to x is going to be cosine x. Good. I was hoping that'd be the same. And then second partial with respect to y. Well, let's take a look. There's no y here, so the partial with respect to y is to be 0. Okay, so here's my Hessian. So what I have to do now is I have to plug in my x and y values. So I want this to be at, specifically I had k pi 0, grab another sheet of paper. Oops. plug in kpi for x, plug in 0 for y. It's going to give me this matrix. So I get negative 0 sine kpi, and then I'm going to have my cosines are at cosine kpi, cosine kpi, and then this guy down here is going to be 0. So there's my Hessian. And I can rewrite this. These guys are going to be as clear as I can get it. Alright, so clean this up. This diagonal is going to be zeros, and cosine of k pi, well, it depends what k is. I could be, again, if I'm on my unit circle, my k pi's are over here and over here. In either case, these are the same entry. It's either 1, 1, or negative 1, negative 1, so we'll do plus minus. But keep in mind these are the same sign, so it's either plus 1, or minus 1, minus 1. It's never plus 1, minus 1. That would be ridiculous. These are the same. Okay, so now, here's my Hessian. I've got two options. Option 1, we find eigenvalues. So, to find eigenvalues, I take this guy, 0, plus minus 1, plus minus 1, 0, minus this matrix, and I find the determinant. Okay. And actually, specifically, I find that that determinant is equal to 0. So you can always abbreviate this and go straight to just making that subtraction if you feel comfortable with it. So it's really a determinant of, well, 0 minus lambda is negative lambda. Still got plus and minus 1, minus 0, plus minus 1, minus 0, and then 0 minus lambda. Okay, and then this is just going to be this times that, so if you think ABCD is AD minus BC, so this is negative lambda times negative lambda, and this will be minus, then I'll have plus or minus 1 times plus or minus 1, which will be equal to, so negatives will cancel out, I'll really get lambda squared minus, and then whether these are both plus or both minus, it'll cancel out and become positive, but I've got this negative in front, so it should still be minus 1 either way. Right? And I'm saying this guy equal to 0. Well, hopefully you remember that this factors into lambda minus 1, lambda plus 1. If not, you can always hit it with quadratic formula, you get the same answer, which tells me lambda equals positive or negative 1. Okay. So, more specifically, lambda 1 is 1, lambda 2 is negative 1, and now we check this, so remember you should have a checklist somewhere, it's also in the book. We can write this as, so lambda 1 is positive, so it's greater than 0, lambda 2 is less than 0, it's negative, so these have opposite sign, that means I'm at a saddle point. So, I got all messed up. Ew. Yeah, so all of my kpi 0 points are saddle points. So all of my critical points are saddle points. There is no maximum, there is no minimum here. No relative maximum or minimum. Okay. And if these were the same sign, then it would be either a maximum or a minimum. Both positive gives me a minimum, both negative gives me a maximum. that was option 1. So if we go back up here, I'm going to rewrite this Hessian on, nope, can't see that side of this page. So here again, oops, and the camera over. So remember, my Hessian at this specific point was 0 plus minus 1 plus minus 1, 0. So now I've got option 2. Option 2 says, just take the determinant and hopefully that'll tell me something good. So the determinant is going to be, again, kind of crisscross, so 0 times 0 minus plus or minus 1 plus or minus 1. Again, these guys, doesn't matter if it's positive or negative, it both turns into positive 1. But then I've got this negative on the outside, so I get 0 minus 1 is negative 1. Okay. So the determinant is less than 0. Determinant less than 0 means it's a saddle point. Or they are saddle points. There's a lot of points we're looking at. All of our k-pi's. And that's that. Now recall, I'm just going to write this out. So I just want to point out, if determinant of my Hessian f at whatever point was a critical point was greater than 0, then we take the trace if that's greater than 0, then I've got a min. Put ditto marks. If this guy here is actually less than 0, then I've got a max. But this is only in the case when this determinant was positive, which was not the case here. So hopefully that was clear, and I plan to post these pages onto my website, hopefully by tomorrow, which is, August 13th.